We'd like to welcome everyone to this GENI webinar. My name is Ben Newton. I am a graduate student at the University of North Carolina at Chapel Hill, who is hosting this series of webinars. And we are grateful for the opportunity to do that, and grateful for everyone who has come to participate live, and especially for those who will watch this video after the fact. Before we start, I just wanted to let everyone know that the next GENI webinar will be at the end of October, and the one moment, sorry, it will be Ibrahim Mada from Boston University who will be presenting on managing virtual network function using SDN and control theory. So we hope that you will also consider coming back in another month for another webinar having to do with GENI. It's now my pleasure to introduce to you the presenter. Prasad Calyam is a assistant professor in the Department of Computer Science at the University of Missouri, Columbia. He also is faculty in the Missouri Informatics Institute, and he has a PhD and master's degree from Ohio State University, and was a research director at the Ohio Supercomputer Center at Ohio State University. And he's going to be speaking with us today about deploying network-aware applications in GENI. And so thank you so much, Prasad, for agreeing to participate and present to us today. And we'll now turn the time over to Prasad.
Thank you, Ben. It's my pleasure to be with all of you. I'm going to talk today on a topic which I've been working for several years, which is how to deploy network-aware applications in GENI. I will now start sharing my screen, and you'll be able to see the slides. And if you have questions, please free to use the chat window. And I won't be able to see it, but there are at least a couple of people monitoring it. The talk is mostly organized around motivating why we need more network awareness in applications. So more and more as we look at applications of the future, we are going to be looking at a large scale of data, a large scale of users accessing the application and the data, and performance is at the heart of deploying these applications. So when we think of what our future internet looks like and how performance is going to be integral in deploying and accessing applications, we are looking at sort of a new architecture that needs to be in place. And I'll kind of motivate some of those requirements for that architecture and how we could go about designing a performance-based architecture that's deeply integrated in the applications. And the next part will be a combination of a tutorial, hands-on demo, and some sort of background, really to get you started on using OnTimeMeasure, which is a software we've developed in GENI for several years now. More than 5 years ago, we started doing it. And I'll give you some of the basic services that we've developed that you can start practicing, setting up a slice. And this is even good if you're trying to teach students on how to set up a distributed application and have web services talk to each other and have this application be controlled through a user interface or a command line script. So the second part is mostly around the reference implementation of this architecture in terms of OnTimeMeasure, and we'll go through a hands-on demo part there. And the last part is a case study on how the network awareness in an application, in this case I'm thinking of virtual desktop clouds, how we could use it to do some dynamic resource allocation. So that's kind of what I want to cover today. So let's get started on the future internet applications and what I think are some of the performance requirements to integrate the applications closely with the sort of ability to visualize and know what's going on in your application. So I have this picture that shows that applications, in the future will be distributed. It will cover both wireless edge and sort of a core cloud. It will have a large scale. It will have many people accessing resources simultaneously in a virtualized world of resources, and we'll have very many federated resources that we'll be accessing as we consume applications. And so, given future where our applications are going to be distributed and the scale of the application is going to be very large, we can't do everything manually. So the hope is we will get close to making autonomously a feature of future applications. So the ability for applications to discover resources automatically, self-configure, self-manage, and self-optimize by analyzing the status of the application. So these features really are critical for the applications of the future, and the performance intelligence that's necessary to realize this future is sort of at the heart of how we will think about applications. So an architecture in that sense could really be looking at a series of services, and I can think of this as sort of a measurement operating system, just like we have a desktop operating system or other operating systems. You can think of a measurement operating system that's composed of very many services, and I have shown here there's at least two services at this user slice level where your actual application will reside, and that would be a measurement point and a measurement controller where all of the data is being collected, and actually measurement collector, so where your measurement data is generated and collected. And as you see, the volume of the data will be very large there, and as you go up into the application visibility layer, you're going to have intermediate services that can orchestrate these measurements, visualize them, store them, archive them for query, and the application will really not consume a lot of data, but it will really seek intelligence from this data. This is sort of an architecture I think will be this measurement operating system serving future applications. And the vision for such an architecture really came from the GENI Instrumentation and Measurement Working Group. I have shown a picture here, and the amount of work that it takes to develop these services and integrate them in your application is quite a big task. And if every experimenter went ahead and tried to, get all these services going for their applications, that would be a lot of work. And in fact, many people try to do it, but don't do it very well. So how about we create a service that most people can leverage off of, and that removes the burden for the experimenter to want to go build a measurement operating system for every application that's being deployed in GENI, which is sort of a future internet testbed. So that's kind of where the motivation for that architecture and the services I'm going to talk about next in detail have come from. And if you had a service like that, what are the sort of things you could do, right? So one of the basic things if you're running a GENI experiment is you want to ask if you got the resources you wanted. So you wanted a link with 10 megabits. Does it have 10 megabits? Does it have 1 megabit? So also if you are using that environment to collect data and you're trying to find problems that might be affecting your results, are you able to trace them from some sort of performance data? And again, if you're more sophisticated in kind of instrumenting your application, collecting a lot of data, you might have several metrics at the host level or at the network level. And you might also want to do some analysis of looking at some obvious changes, or you want to maybe use some forecasts based on the data you have. And you might want to archive this data also for some other purposes. So for many of these reasons, you need a instrumentation measurement service, and that's sort of what I'm going to talk about next is a reference implementation of an instrumentation measurement service we call as OnTimeMeasure that we develop. And here is sort of the plan that I will give you sort of a background, and then I'll show you a hands-on demo where you can get started. And there will be parts where I'll skip ahead, but I have a detailed set of instructions on the wiki, and I encourage you to go through that after my webinar and will be available to help you. And then I'll conclude with how you can kind of get familiar with these services and also customize it for your application. So that's the adding the custom metrics of your application part I'll talk about. So coming into that portion, which is the on-time measure portion, I encourage you to look at our wiki, which has plenty of information. But again, the goal was really to provide a set of measurement services for experimenters, and it's a software that will do a lot of these services I talked about, and it basically starts off with this researcher web portal, which is ontime.net.measure.utility. It's an instance of what we call as the on-time beacon that's running, and hopefully, if you've done the pre-work, you have an account registered. If not, you can always go get an account there. You will need that to follow the demo. And also, this measurement service has a command line interface also that you can use to control the various services. And the main sort of terminology is this heart of the on-time measure, which is we call as the root beacon and node beacon measurement instance. So the root beacon is sort of the core which holds all the data and the visualization. Node beacons are more like the measurement points. So root beacon acts as the measurement collector, also the analysis presentation service, and so it is the more sophisticated part of the software. And node beacons are sort of the points that you would instrument with your application. And so we expect the users on the left side, as you can see, providing information of what your measurement requirements are, and that gets translated in your measurement instance within your slice with the node beacons and root beacons orchestrating the various measurement services, and all the data again will be accessible in raw or processed form that you can either get from a command line tool we call as on-time control, or a web portal that you will use, which is called on-time beacon. So the account that you will register will basically take you to the web access of all of these services. And a little more detail, what you'll see today is sort of an example setup of the node beacon to do some active measurements, and the tools that we'll be looking at will be pings and trace routes and the obvious iperf sort of tools that you can schedule. You could use any other measurement tool to sample your data, but this is sort of a simple example. And again, we'll go through some of the features of the root beacon and look at how the data is collected, visualized. And you can typically run many node beacons depending on how distributed your application is. And you could also run a root beacon on the same node as a node beacon or a separate node, whichever makes sense. And the last part of what you really can get from using on-time measure is the ability to do data aggregation and having some control on when you can start collecting data, stop it, how to store it, what kinds of data you get to store, and then data visualization. So we have some ability to do some analysis on it, and graphing and some dashboards if you want to monitor your slice. In terms of the analysis, we could do anomalies, some forecasting. You could look at even downloading some raw data and maybe archiving it, or or if you wanted the whole slice as a whole of all the data that's been collected, you can download it as a sort of a SQL dump and things like that. So there are many features that you can experiment. So let's get into the tutorial part of today's talk. So the plan is that hopefully you've gone through the wiki and seen that there are three things you need, which is hopefully the pre-work instructions. Hopefully you have access to that. And then hopefully you have a document, which is the step-by-step tutorial instructions. So we'll kind of carefully follow that, and hopefully have these slides also, so if you want to follow along. And so we will start with how to set up on-time measure and configure it to collect some data, and we'll use it to basically control some measurements, get some data going into a database, and then we'll see different ways to query it and the last part, I'll add a custom metric to this setup. So that's kind of what we'll go through in step-by-step fashion. And as I said, hopefully you have those instructions with you. And
Prasad, I have placed in the chat window the link to the page that has all of the information about the webinar on it, including links to the slides and the instructions that he's talking about for the tutorial. So you can go there and find all of that information.
Thank you, Ben. So as a pre-work, hopefully you know how to log into the portal.geni.net, and you know hopefully how to join a project. In this case, I've created a project called OnTimeMeasure GENI webinar. You can join that, and I can approve that. Or if you have already a project that you use, you can use that also to create a slice. And hopefully you have your key pair that's in your GENI portal. And if you have all the GENI portal part set up, the other pre-work is to get an account on the OnTimeMeasure-enabled, which is the OnTimeMeasure portal. And that's again sort of similar to the GENI portal. You request, and then here I need to approve it, and then you have access to the portal. So here is sort of how we get started on the demo. So let me go and show you the GENI portal. I have several projects here. I'm teaching a class this semester. This is for the webinar I created, and our lab has a project. So you could have many projects. You could join any of the projects you have access to. The first thing is I can show you how to go in and create a slide. So I've been creating some slices here. So you go basically to the create slice, and the instructions for the webinar, as I said, there is this PDF document, and I'm basically going through it kind of top down. And the part, if you can go to the part after the pre-work, you've seen the pre-work steps, and if you've done that, we are basically in the design setup stage here. So I've logged into the GENI portal, and I need to basically create a slice, and I can give it a slice name. So in this case, I will give NetAware 6, for example. And you can say it's the OnTimeMeasure tutorial, and you create a slice. And the first step you do is basically add resources. And if you go back to the PDF here, we basically give a URL from which you can copy and paste an RSpec. So you would click a URL here, and you paste that. And what you will get is basically a simple, OnTimeMeasure instance with 2 nodes and a root. And you basically pick for the site any aggregate manager. In this case, I'll pick, say, the Missouri GENI rack. And I would basically say reserve resources. And this is the part where it takes a little bit of time depending on what's happening. I will kind of go to an instance where we've already sort of set this up. So following the instructions again, this is what we did. We gave the URL for the installation. We have given the site, and we've asked to reserve resources. And once the resources are ready, you should see a status that says finished. And typically, when you have the resources ready, you can SSH into them. So now I will be going into a already set up, instance, which I think is that. The point here is you should be able to SSH into the instances to install the software. So here we're kind of doing it manually. We're going into the root node, root beacon, and installing the root beacon software. We're going into the node beacons and installing the node beacon software. But you could automate that, or if you're doing a larger deployment, you can use some sort of a configuration manager to sort of get your software installed. So we are basically in the software setup stage. And in this case, we've actually set up the software already. So I'm using this Fire SSH plugin that is kind of handy if you are using the GENI portal and you want to actually log into your slice nodes. So you should be able to do that and get access to the, let me see. So I'm guessing it's already connected here in this case. So that's probably the reason. So if you have already installed it, you can go to your temp directory, and as I'm showing you here, all of the software will be installed on your root. And again, the same thing you do it on your node beacon, and that's kind of the instructions we're saying here is if you have a Fire SSH or some plugin, or you have some other way to SSH into your nodes, you can access it and basically give these commands to download the software, and you have to give a password, which is kind of your OnTimeMeasure instance password, which you need if you're going to own all of those services. There's a couple of places you need to give that information, and once the software is installed, one way to check that your software has been installed and all the services came up is to basically go to your root beacons node, which has a supervisor running. In this case, I have the supervisor that's already been running. I can refresh it, and you can see basically the various services that are running for the visualization, for the collection, for some of the root services. And similar interface is also there for the node beacon side also. So if you have followed the instructions that we've given here, and you have the node beacon and root beacon running in the nodes that you're interested in your slice, you should see the supervisor indicating that all these services are ready for you to use. So that's really about the setup. And as I said, this is even good for a class where you're trying to show the students how to set up a distributed application and think about how in the next steps you can have a way for web services interactions for these application sort of actions. You can ping your nodes, hopefully the node beacons and your root beacons, you should be able to ping them. And the next step is to really start using the either the command line interface or the graphical user interface, which is the on-time beacon, which is this ontime.arnet.missouri.edu. So you hopefully have an account there already. So let's go here. So if you go to the home page, you log in the first time, it'll ask you to basically set up measurements. So here we've gone a step further. So in the setup again, you could have a more easier way to upload a lot of these information of where your nodes and root are, or you can do it manually. Here we've shown a simple example where you've given the information, and once you have given the on-time beacon information and you have updated it, you will see that when you log in, you will go from setup measurements to manage measurements. So that's kind of where we are now. Is I have already given the information of where my nodes and the roots are, and I'm ready to start adding some measurement tasks. So I can pick various metrics. And as I said, by default, we have some throughput and other kind of metrics. We could add some other metrics if you want, host-based metrics or network metrics. So basically, you add them, and this is like scheduling your measurements essentially. So it's almost like booking a flight ticket. So you basically make sure you got all the measurements you need and frequencies you need. And this is very simple for the tutorial purpose, but if you have actually access to all of the code on your node root beacon instances. So if you want to change the sampling rate or change other things in the code, you're able to do that also. So when you submit it, basically you can see this is live status that all of your services are running. And if you think you're ready to start collecting the data, you can just say start service, and your measurement service will basically start up. So going back to the instructions, this is kind of what we did. We added the measurement tasks, and we basically submitted the schedule, and we started all of the measurement services. This takes some time depending on what data you're collecting and how long you're collecting. And if you have some measurements running, you should be able to basically query the measurements. And in this case, we have not yet uh, collected enough data, or maybe there's one or two data points here. So you can see, you can get the raw files, get some anomaly detection sort of scripts to run on your data. You can have some kind of forecasting scripts to run on your data, and you can also go and view your dashboard. And the dashboard, essentially, I have an example here. You can basically use this graphite that's integrated into the OnTimeMeasure software, and it's just a graphing engine. You can change what data you want to see, what time ranges you want to see, and it's kind of handy. And I'd encourage you to basically go in and check out some videos if you really want to see more on the various services. Actually, I think I have it in a different browser here. You can basically go to this demo link, and I have that in the slides also. So this demo link gives you basically several videos if you want to follow through some of the features we have developed and get into this graphite. And I can show you basically the more of the dashboard. So you can see all of the other things are given here, but the dashboard is kind of easy to use. And I show this because it's easy to query the data, not only visually like this, but you can write a simple HTML website. If you have an HTML website, you want to query a graph, it's easy to do that from this graphite service that's running on your root beacon. So you can change the hour, the date ranges, and as I showed you, can add different kinds of metrics to the graphs, remove them, label the axes. So this is kind of a very interesting, powerful graphical tool you can use. And one of the things that I found handy is there's also sort of this command line way to give various queries to the different data that's in your slice. And you can see all these graphs that are generated. And if you're running your slice for a long time, you can basically save these graphs as a demo, and then you can sort of load your demo, and you can have a number of performance metrics of your slice be continuously measured. So this is kind of your NOC for your slice. You can create a mini NOC for your slice. So that's how to get the data, how to visualize your data. And coming back to the slides, so that's kind of where I've shown you. And also know that you can do a distributed measurement, so you can get on-demand measurements running just like running on your command line between different nodes. You can run a distributed measurement configuration also. So that's basically a sort of a tour of how you set up the slice with OnTimeMeasure software, the node beacons and root beacons, and then how you can start your measurement services, and how you can query the data, and different ways in which you can interact with the data, either graphically or through a command line, or even if you have a HTML page, you want to pull some graphs, or you want to create like a NOC field to your slice. I kind of showed you some of those steps. And there are more instructions in the document. And one of the last things for our hands-on part is how to customize your application with OnTimeMeasure. So how do you add your metrics into the OnTimeMeasure? So we basically followed the same steps to add the network metrics or some of the host metrics I showed you in the demo. So say if you have file transfer time, or access time for a large file, or you have other metrics that maybe related to your video streaming, or maybe related to your web application, or some other application you're running. All those metrics you can basically integrate into OnTimeMeasure using this feature. And to understand how you do that, here is a sort of a basic understanding of how we have metrics be added. So we think there are four abstractions. So basically, there are control actors, which is the owners of the slice, and there are data sources. So where is your data coming from? Is it a passive data? Is it an active data? And so there is some sense of where your data source is going to be, and hopefully you have a script that is able to get that data, have it in some kind of a time series if you're going to be monitoring it, and that script needs to sort of describe to OnTimeMeasure the data structure. So what is the data you're collecting? And the control actions are basically to figure out what's the frequency and sort of what kind of analysis you want to do the query and things like that. So all of those abstractions, if you understand, you can basically set up the custom metric for your application. And if you go back to the instructions, and again here I just sort of told you what I just here it shows basically what I just told you. If you go back to the instructions, there is a set of steps to add a custom matrix. So you go down all the way to the bottom of this demo. So this is kind of where we're installing a CPU metric, and we have sort of packaged it to be added easily for this demo. And then if you really are interested in going through all of these steps for your own application, there is also a wiki on the OnTimeMeasure wiki page where all of these steps you need to take to add your metric are sort of detailed, and sort of the more details of the steps. And we've sort of gone through that and made it easy to follow a hands-on example here, but you can do the same for other applications and other metrics. And so after you've done all of these things that are part of our tutorial, you can basically finish up and release your resources. So that was sort of the part where hopefully you have a better sense of what it is to instrument your application, get the right visibility of your slice from a node, or even from a network perspective, of the various metrics and how you can interact with the performance data. And the last part is how we have taken this and actually put it in the context of a couple of application case studies. And the overarching application here is virtual desktop clouds. And I think this is a future internet application in the sense that we started doing this about 6-7 years ago. And today we have Amazon workspaces, but in those days, most of the enterprises had a virtual desktop infrastructure, but nobody really put them in data centers and managed virtual desktops across data centers sort of in a cloud way. So we had started this as part of a first generation GENI experiments where we set up virtual desktop cloud instances in GENI, and the idea was that you could have thin clients access these virtual desktops in the various data centers, and at the heart of the logic for the orchestration is this unified resource broker, which is really where all of your measurements really get analyzed and all the decisions for the resource allocation happens. And the story was basically how the awareness is critical, right? So if you didn't have the right awareness, you could have a research scientist or a home user or a mobile user accessing these desktops, and they would have different requirements based on what applications they're using. And if you kind of went with a fixed allocation scheme. So this is kind of what you do in your home. If your mother, your brother, your father-in-law, or your mother-in-law wants a computer, you just go to Sam's Club, buy the latest one, and maybe it's great for your father or mother-in-law, and your brother will say, this is really bad for my gaming, right? So if you try to do this sort of a fixed allocation of whatever you think is sort of an average fit, or let's give the same thing to everybody, that kind of doesn't work because A, it's expensive, B, like I just said, it will work for some people and others might be unhappy. So if you can think of a provider giving hundreds or thousands of desktops, such a scheme of fixed allocation or sort of guesswork of what somebody needs can be pretty expensive, and you have unhappy customers. And the problem again there is the awareness of who the user was, what did they need, and what sort of is the right utility function of the applications in the desktop that I need to deliver as a provider, and what's the cost and other performance issues that needs to be done. So if you're looking at the awareness side from sort of who the user is and what my resources should be capable of, that's sort of where we are going in and getting this awareness data to the unified resource broker, and we call that a URAM scheme, which is different from the FRAM, which is a fixed allocation scheme. And in that case, you can proportionally size the desktop resources, and so everybody is happy and the provider is happy also, right? So this was sort of the use case in which we integrated the awareness of the application with the sort of the network and the host. And a little bit more detail of the various components that are involved, and essentially the measurement acts as a measurement plane, the measurement engine where we're collecting all this data, and then there is some interaction of the awareness at the service side. So at the data center side, you see the service engine that's actually provisioning the desktops. You can have the awareness to exercise the desktop, figure out the security or the type of thin client server that needs to be there. And also this awareness can be sent to the routing engine, where if you are doing open flow to basically connect the clients to the server, which is hosting all the desktops, you could figure out which paths the desktop session should go through. And if you're controlling these open flow switches, again, the OpenFlow controller has a decision engine that looks at the measurement plane data and then orchestrates the setup. So the next slides will basically show you how we kind of realize this FIPA implementation for a virtual desktop cloud. So which basically is trying to control the service engine, the routing engine, and mediating the desktop connections. So we did this first experiment way back in GC10, and we compared URAM and FRAM. We basically created a data center in our VM lab, and we had some clients from GENI connecting to the data center, and we had a web portal, obviously, for the demo, and at the back of it, we were leveraging path-based measurements, host-based measurements, and in this case, some of the custom metrics were coming from some of the VMware VDI tools that we were accessing in the demo. And so we set up basically this sort of a idea of a MATLAB point cloud visualization. We were able to show that in a setup with fixed allocation, you basically had improved performance with URAM. So if it was the FRAM horse, which is this blue horse, it sort of had an irregular rotation as the point cloud was being shown. And here we're showing a MATLAB application in the desktop. And in the next case, you can see both were smooth, but we were winning. Our horse, which is the URAM horse, is winning because we had increased scalability. So we had more desktops with smooth horses than an FRAM desktop pool. So that's how we showed that in this case both were smooth, but we were able to run more horses smoothly. So we are still winning in terms of scalability. So the awareness basically made you scale better and also perform better. And another demo we did where the network awareness and the host awareness was critical is to show sort of an open flow kind of a demo where we are able to place basically where the desktop should be and how the user should be connected to the right desktop and the right QoS conditions in the network in the middle. So we had some backup paths, and we had a open flow controller set up. And again, we used our VM lab at Ohio State and EMU lab at Utah, and we're collecting same measurements that we did the last time and some more. And the setup is shown here. So we basically created a slice setup where we had multiple data centers, and the thin clients were automated to connect to the different data centers, and there was some cross traffic that was introduced of other applications on the same paths that the clients were trying to access the virtual desktops in the data center, and there was a congestion point, and we showed how in real time we could sort of have the backup paths be used to divert the traffic and make the congestion go away. And how we showed the demonstration of the application was, so we had a setup that was running, and the applications were running fine when the thin client connected. So here we're again showing horses. So we're winning. The horses are running smoothly. And here is where we had the adversary come in. The cross traffic came in and sort of crushed the performance. Again, our horses now are not running so fast, so we are losing. And we did the the traffic steering and sort of the backup path utilization, which made the cross traffic still run okay, and our horses again are running okay, so we still win. And in the background, you can see the data that was collected showed us the awareness of this setup is in the first case, when the route was set up, we had our application using 4.6 megabytes. It was running okay, and it was crushed by this cross traffic, which made all the freezing happen. And once we were able to do the backup path traffic steering, you can see that both the cross traffic is happy. We are happy. So this is sort of a good example to show you how much critical the visibility plays, and how from an application perspective you are in much control, and you're able to validate your adaptations in your slice with some actual performance data. And it's important you have it in real time, and you have it for a variety of metrics, so you can take the interesting actions on your application decision side. So that sort of concludes the talk part and sort of the hands-on demo part. And I encourage you to go through all of the instructions in the PDF, and you can always email me if you're trying to follow through the demo for the rest of this time that we're going to be on this webinar and later. We're happy to stick around and help you. And I have given a couple of references that has more details on this talk that I just gave you in terms of the on-time measure development and the services, as well as some of the application-aware experiments that we've done in GENI.
Perfect. Thank you so much. What questions does everyone have for Prasad?
I have one question.
Yes, please go ahead.
Yeah. So I want to measure the traffic goes between two GENI nodes. Can we do that with the on-time measure?
So are you talking of doing like a packet capture?
Yes.
Yeah. So
I only want to know the amount, traffic amount. We don't need to know the exact traffic. I don't know the traffic amount. See how many traffic amount goes between two nodes in certain, say, in 1 minute or in certain time period.
Right. So, I mean, if you're looking at doing a packet capture and doing some analysis, we have some instructions for that on the OnTimeMeasure wiki. If you want to really query network devices for such kind of information, I'm sure the GENI NOC has some interfaces for that. But if you want it to be part of your sort of NOC for your slice, like I said, again, that would be a custom metric integration. So we don't have any existing network device information be sort of published in the measurement software. So, but the easier way, if you're really just looking at the nodes you're interested in, and you're able to do packet captures and look at it, that's something we're able to sort of schedule those packet captures and get those data out for you.
So we just need to run the packet capture software on the nodes, and then we.
Yeah, and again, those can be thought of like a passive tool, right? So I showed you active tool where you would have a tool run, every hour or every 3 hours, and you had a way to say where to run it, when to run it, And again, in this case, if it's hyper for something, how to run it, you can give some commands also. So same thing for your packet capture. It could be another tool like hyper for anything that you would integrate into OnTimeMeasure, and through the same interfaces, you would be able to say when the packet capture should start, and if there are any command line options you want to change. All of those you can sort of automate, so you don't have to log in and do them manually, so that you can sort of have a more automated control on it.
So is there any existing metric, like we don't have existing metrics like this, right?
So the existing by default, as I showed you, is mostly network path metrics, active measurements, some host-based measurements,
Yes.
and like I said, the packet capture is there, and we've done it for VMware tools and other tools, like I talked through the slides. But the wiki that I showed you, which has the custom metric integration, if you can follow that, I hope it's not too difficult to add a metric. So please let us know if you are planning to use that.
Okay. Thank you very much.
I have a question, Prasad. What do you have a feel for the overhead of some of the metrics for testing them?
Yeah. I mean, that's really very important. If you're running some active measurements like iPerf and something that's either network intensive or CPU intensive, that will affect your application in the slice. So typically, your measurement infrastructure is sort of separate from your application infrastructure. It's in parallel, but you have to be careful that you regulate your measurements so they don't overwhelm your application. So that's a little bit of uh, you know work you need to do to figure out how to schedule your measurements so you're not interrupting your application. So one example we use is, so we're running this physical therapy application where a physical therapist would connect to somebody in a Google Fiber home to run a physical therapy session. We wanted to first qualify whether that link between the therapist and this home is good, right? So in the application we had a button that would basically say, can you give me an assessment that this network is good for this call? And we know what the application needs. We kind of can do a sort of a eco ping test, right? You can do a test and say, it looks like a good path. When you start the application, it's going to work well. So in that case, the measurement helped you pre-qualify, right, before you start your application. So it's not like you start your application, solve the problem. So you at least had a thumbs up before you start using your application. And during the application, we were again sampling, sort of the bytes in, bytes out, and various other kinds of application metrics. And again, you could be doing pings and sort of the lightweight measurements on the network health, but you wouldn't run anything heavy then. And if you're running something which is built into Microsoft operating system, and you're able to query some metrics like we did, those don't have much overhead on the application. So again, it's something you have to go back and as you instrument your application, you should get a sense whether the way you're sampling, the rate at which you're sampling, does not affect the application behavior. So yeah, so it is an issue that has to be sort of worked out. And depending on what you're trying to do, what's your monitoring objective, you would basically do the right sort of scheduling or the configuration of your measurement service.
And when going through the tutorial, you set up the individual metrics to trace, and I think the option was periodic on the right hand side.
Mm-hmm.
What's the default period, or does that depend on each metric? And what are some examples of that?
Yeah, so right now for the network health, it's probably an hour or half hour. So, the granularity is very big. And like I said, when we have some CPU and other kinds of things, those are more like seconds. And so different metrics will have their own sampling frequency. So that's why in the custom metric slide I showed you, when you're adding your own metric, one of the things you would specifies what are the control actions, sort of sampling frequency and things like that. So those would be part of your measurement specification.
Thank you. What other questions can Prasad answer? Okay. Well, I just want to thank Prasad again for presenting today, and as he and again remind everybody that we'll have another GENI webinar in the next month in October.